far beyond the warmth of the sun, in the frozen reaches of the outer solar system. One of Jupiter's many moons drifts in quiet isolation. On the surface, it appears cold and lifeless, a cracked, icy shell sculpted by time and pressure. To the naked eye, it might seem like just another frozen moon among dozens. But beneath that shell lies one of the most intriguing mysteries in planetary science. This is Europa, a moon slightly smaller than Earth's moon, yet it may hold something Earth-like beneath its surface. Not deserts, not rock, not methane seas, but water. A vast, global ocean sealed beneath kilometers of ice. And wherever we find liquid water on Earth, we find life. Could the same be true on Europa? This is not just a question of geology. It is a question of biology, chemistry, and cosmic destiny. In the silence beneath Europa's frozen crust, could alien life be stirring? Europa is one of Jupiter's Galilean moons, discovered in 1610 by Galileo Galilei. At just over 3,100 kilometers in diameter, it's slightly smaller than our own moon, yet it orbits the largest planet in the solar system, a gas giant over 300 times the mass of Earth. Seen from afar, Europa is striking. Its surface is a smooth sheet of ice, crisscrossed with long, dark lines and scars. Few craters mar its face, suggesting that the surface is geologically young, constantly being reshaped. But it's not the surface that fascinates scientists the most, it's what lies beneath. Multiple missions, from Voyager in the 1970s to the Galileo spacecraft in the 1990s, gathered data that hinted at something extraordinary. Magnetic field readings, gravitational anomalies, and surface features all pointed to one startling possibility. Europa doesn't just have ice. It has a liquid water ocean hidden beneath that ice, stretching for hundreds of kilometers in depth and possibly containing more water than all of Earth's oceans combined. Europa orbits 5 times farther from the Sun than Earth. At that distance, sunlight is weak, not nearly strong enough to keep water in a liquid state. The surface of Europa is an airless, frigid wasteland, with temperatures plunging to minus 160 degrees Celsius, minus 260 degrees Fahrenheit. Yet deep below, something keeps the water from freezing solid. The answer lies in gravity and motion. Europa is locked in a gravitational tug-of-war between Jupiter and its fellow moons, Io and Ganymede. As it orbits, the immense gravity of Jupiter pulls on Europa, flexing it like a rubber band. This constant stretching and squeezing generates tidal heating, friction within Europa's interior that produces enough warmth to melt ice into water, sustaining a subsurface ocean beneath the crust. It's the same mechanism that powers volcanic eruptions on nearby Io. On Europa, it doesn't produce fire, it produces liquid water. This ocean is sealed beneath a crust of ice, perhaps 10 to 30 kilometers thick, but below that lies a world of liquid potential, a dark ocean, warmed from within and possibly stirred by underwater currents. The evidence for this hidden ocean isn't just theoretical. We can see its fingerprints all over Europa's surface. The icy crust is fractured and ridged, marked by chaotic terrain that looks like giant ice flows broken and refrozen. These patterns resemble Arctic sea ice on Earth, suggesting that the ice is moving, cracking, and shifting from below. Some regions show signs of cryovolcanism, eruptions not of molten rock, but of water, slush, and ice, pushed upward by pressure from the ocean beneath. These plumes may have erupted thousands of meters into space, briefly exposing the interior to the vacuum of space. In fact, in recent years, The Hubble Space Telescope and other instruments have detected faint signatures of water vapor plumes erupting from Europa's south pole, potentially giving us a way to sample the ocean without drilling through the ice. If confirmed, these geysers are a direct connection between Europa's ocean and the vacuum of space, a portal from one of the most alien environments in the solar system, possibly delivering chemical clues or even microscopic life. Liquid water is the first ingredient of life, but it's not the only one. For life to emerge and survive, even the simplest microbes need three key ingredients. Liquid water. Essential chemical elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. A source of energy to drive metabolism. We know Europa has water, but what about chemistry and energy? Jupiter bombards Europa with radiation, powerful enough to split water molecules on the surface and create oxidants like oxygen and hydrogen peroxide. If those surface materials are pulled downward by ice movement into the ocean, they could provide the chemical fuel for life. Beneath the ice, tidal forces might cause hydrothermal vents to form on the ocean floor, just like on Earth's seafloor. And on Earth, these vents teem with life. Entire ecosystems thrive in complete darkness, fueled not by sunlight, but by chemosynthesis, bacteria converting chemicals into energy at the bottom of the sea. If Europa's ocean has similar vents, rich in heat and minerals, then it could support microbial life, or even more complex organisms. We don't know yet, but all the pieces seem to be there. If life exists on Europa, it wouldn't look like anything we know. It wouldn't need eyes, there's no light. It wouldn't need lungs, there's no air. It would live in complete darkness, under crushing pressure, in water that's salty, cold, and constantly shifting. But life is resilient. On Earth, we find it in boiling acid springs, Antarctic subglacial lakes, and deep-sea vents where no sunlight has ever reached. Microbes have survived for millions of years in permafrost, inside salt crystals, and even in the vacuum of space. Could life on Europa be based on similar principles? Single-celled organisms, perhaps. Chemosynthetic bacteria. Or maybe something stranger, something that evolved entirely independently from Earth. If Europa harbors life, it could be the first proof that life is not unique to our planet. That the universe, even in its coldest, darkest corners, may be biologically fertile. For now, we have only hints, but we're preparing to search for answers. NASA's upcoming Europa Clipper mission, launching in the 2030s, will orbit Jupiter and fly by Europa dozens of times. It will carry a suite of instruments: ice-penetrating radar, spectrometers, magnetometers, and cameras designed to map the ice, measure the ocean's depth, and even analyze the chemistry of possible plumes. It won't land, but it will get closer to Europa than any mission ever has, offering us our best look yet at the moon's structure and potential for life. And in the distant future, scientists hope to send a lander or even a submersible probe, a robotic swimmer that could melt through the ice and explore the ocean directly. Imagine a machine diving into a lightless sea beneath the crust of a distant moon, searching for signs of alien biology. It would be one of the most ambitious explorations in human history. The question isn't just whether we can find life, it's what it would mean if we do. If Europa's ocean contains living organisms, even microbial ones, it would change everything. We would know that life is not a fluke, not a miracle confined to Earth, but a natural outcome when the right conditions exist. It would suggest that biology might be as common as stars, that the cosmos could be teeming with oceans, ecosystems, and alien life we've yet to imagine. And if Europa, with no sunlight and a sealed ocean, can support life, what about Enceladus, Titan, the subsurface oceans of distant exoplanets? The implications reach beyond science. They reach into philosophy, religion, and identity. Because in finding life out there, we may better understand what it means to be alive here.